Hi, I'm Aaron, and one, maybe two retro. We're finally at the day where that low number, 224,000 bread pin that I picked up back in April, is going to get open, and we're going to have a look at it. During tests, as I had mentioned previously, is that we were getting some weird characters on the screen. Everything else seems to work with it all right. You can see it's a very clean machine. I'm very impressed by how well the owner kept it. It is a very, very, very low P number. You can have a look-see inside at how clean and nice the insides of this look. Like, it is gorgeous. And if you look, and I have registered it already, it is the 243,040 out of the Pennsylvania factory. It is an original 5-pin DIN video, so we're only going to get composite out of it today. We aren't going to be using the power supply that came with it today. We're going to be using a known, trusted, working power supply. So let's jump right into it. What we're going to do is we're going to open it up. We're going to run a test on it. We're going to try and figure out what's causing those weird character anomalies, and then we are going to try and fix that. I should have all the parts here today. So, screwdriver in hand. Unit flips over. We only have 3 screws at the front on the C64 bread bin. This is going to be a very easy opening, as long as the heat shield is not affixed with solder. Okay, and here we go. Oh, look at that. Isn't that pretty? Okay, so we have a little bit of rust here. I'm seeing a little bit of dust, but the caps are looking really, really good. And you can see here, let me get my pointy stick. You can see here that the back shield has already been desoldered. So there may have actually been some work on this board already. I thought it might be untouched. I was hoping it was untouched. Okay, so we'll remember that we have the red wire leads towards the red, and the red and brown wires here lead towards the same back. Okay, we'll take those off, and we'll just set the keyboard and items aside for now. So again, we have this beautiful unit that looks like it's in really, really, really good shape. The other item that I'm not too sure about is the SID chip. We have run some tests. I'm not sure if the SID actually is playing properly or not, and I'll have to do some comparisons. There is a bodge right here. This is a standard factory installed bodge, but you'll notice, I think normally you actually have to cut that leg to be able to enable the reset. And I know that through using this previously, the reset isn't working from a cartridge, or at least it wasn't working with my Sidekick. You'll also notice that R36 is, I think, missing here. But you would use R36 here again as part of that cartridge/reset circuit to allow things like snapshot cartridge, to allow some of the more modern cartridges that use reset with keeping the memory in place to be able to do some of the magic that they do. Okay, so before we power this up, I think it's important to know that It looks like the board's been into before. I'm going to leave the board intact, and we're going to run a diagnostics against it. So again, I'm using my C64 diag card. When I look up the pin settings, we already know it's not dead. So what we're doing is just a full end-to-end test of it. We aren't doing this 22 star, so we're going to change the dips here to off, 3 on, and off. There we go, and that will go into the cartridge port. Okay, I am using a 5-pin cable for video, so it's going to be composite only there. I do have a known good power supply, but it's always good to verify using a power saver and use that as your power in. And then we connect the rest of the harness to be able to test all the components of the computer. And then you'll see the challenges that I was describing. I always forget which one of these is. So this is controller 1. This here. Now, again, as I like to say, full disclosure, but I have had this already hooked up and running, but for the purpose of the viewer, I think it's important that we actually run the entire test. All right, pin 1, good question. Pin 1 is, great. Pin 1 should be down by connection 1. Let's put that in. Too bad this isn't keyed, but you'll notice it is keyed for the keyboard. Pardon the pun. Is keyed for the keyboard. Okay, so there's our test setup. But we have the test harness hooked up. We're going to turn it on, run a full and system test, and hopefully I got the keyboard plugged in the right way. And then you'll see the issue that we have, and then we will disconnect. I believe it's character ROM that's causing this issue. So here we go. We have our test running here. It's looking good. Of course, the Glotto has no signal because it's horrid. We'll just turn it off. Start recording. So we're going to do that again. You'll see I can use the reset here. And it does reset it. That's very interesting. I'm not getting the character issues that we had earlier. There we go. Okay. You're going to have trouble. So if you look at the A and the G under 0 page, you're going to see characters starting to flicker. Sure. If we ran a disk test on this, that's where I saw these errors clear. Keyboard is bad. Okay, we're going to turn this off. We're going to do this again. Sadly, I think pin 1's down here. But let's see. It is. Shoot. Okay. So doing this again. You'll see little lines popping up under the G, under the E, under the G of 0 page, etc. That should not be there. That is certainly an error. And we don't want to see that error. So here we go again. So right now it's saying the control port's bad. That's interesting. Let me see if I can reproduce this for you a bit better here. I'm just going to put the diagnostic cartridge into the 1541 diagnostics, where we seem to see a lot of the residual issues popping up. Okay, so you'll be able to see under the head exerciser, the R's are flickering. I believe by replacing the character ROM, hopefully with this good one, we will be able to resolve that issue. So, in theory, I have, yes, I know they sent it to me in a DVD case. I have a couple chips here. I have a PLA and I have what I believe is a MOS chip wrapped not in a static sensitive bag. Obviously used a MOS 901-22501 CBM, copyright 1982, which is this chip right here that I suspect is causing this flicker. Okay, so we're just going to unplug for safety. Just going to double check that I am grounded. I am going to get some splooging tools so that we can do the minimum amount of impact to this chip. And yep, that's good. This is great. This is, oh, that's not great. Should be more gentle. So I did bend the pins a little bit there. Thing that I can't just bend back, but we're replacing this chip. So let's be a little more gentle with this one. Nice, comes right out. Well, at least they put in a nice protective package. Okay, those pins look about the same. And you know what? Before we do anything in here, we're going to do Adrian Black's favorite deoxit. We'll do the same on these pins. Actually, what I'll do is I'll put some on this Q-tip here, and we will clean those pins right off. Just get a bit of excess up here. Look how nice and clean that board comes. So there is some dust on this board. Yeah. But we will, there we go. All right. Moment of truth. Look at that. That was the issue. We fixed it. It was that easy. So, we know that this chip is semi-good. So we're going to put it back in this makeshift interesting protector. We're going to mark that chip, which is my little red dots, because I like to be different. And when a chip is at least working partially, I put orange. And then if I ever need it for testing purposes, I know what the issues are with the chip, or at least I have a general idea of what the issues are, and I know that it's not good. Just like the SX64, I replaced the PLA, and yeah, that was a 1982 chip, and I replaced it with a 1982 chip. Let's put it back in its other diagnostic mode, and then let's see if we can correct that control port issue, which I bet you is dirty pins. Because there's absolutely no other issue going on with this board. We'll put the drive unit back in. I unplugged that because I was concerned that it might actually try and do drive access with a drive test, and I just wanted to show you the issues that I was seeing. Hopefully this is just quick and sweet. By the way, I did remove the heat shield here so you could see the insides. Then you know what we're going to do. When this is running through its test, we're going to yeah, like it's not running right now. Sorry. Anyways, we're going to take some temperature readings, which is the other cool thing. I have this new toy, and we're going to play around with it and have a look at, you know, that's 37 degrees. That's 33 degrees. So we're going to take our registration of each chip and understand how hot it is. And I'm going to do this with every computer that I work on, and we're going to start a little registry, and we're going to see what no good computers, what temperature they should or are running at. So the other thing I was really interested about this computer, segue, as I do, this computer is working perfectly exactly the way it's designed. It's a relatively low number. It's under 250,000 of the first ever built out of Pennsylvania, which I believe was their main first manufacturer. Could be wrong. 224,145 by the inside serial number. And as we talked about before, as I showed you before, the outside serial says 243,040. Interesting. Either way, it is an old, I'm not sure if you can see it here. It is an old 326290 Revision A board from 1982. We know it has the bodge that doesn't completely fix the reset. At least allows it to reset, but doesn't allow advanced features on reset. Doesn't allow it to retain memory properly. I'm just going to unplug this. I don't like pulling things in and out of cartridge ports when it's plugged in. Wow, that was tight. We're just going to do a little cleanup here. Let's just take that out to make it a little easier. We'll get a little bit of deoxide here, on here and here. We'll just take a Q-tip and run over that. Oh yeah, look at that dirt and mess that's on here. Look at what's coming off of that. Definitely not clean, but still, for its age, considering it's 42 years old, in great shape. And if I didn't have the sneaking suspicion that it actually is... I'm going to get some magic eraser. This is... and a fiberglass pen. Yeah, getting these clean this way is not working too well. I don't know if you're going to be able to see it at this angle, but hopefully this is enough to, oh gosh. To get a better contact. Now I have some cassette decks that I could use for testing this, but again, I mean, the test harness is fairly reliable. The really interesting thing about this test harness is it was throwing me constant errors on everything I was testing, and I thought it was just the SX64. But apparently, one of these pins, when somebody put in the IC in a brand new test cartridge, bent the pin leg all the way under, which didn't allow it to test properly. Almost all parts of the components. I mean, it could do the memory test. I just... It could do the dead test fine. Well, it doesn't need these to do the dead test. This is awkward. All right. So, moment of truth again. It really helps if I plug it in, though. Now, certain individual, I was making comments about older Commodore 64s and whether they should actually be upgraded or not. And yeah, I'm thinking about just preserving this. Preserving it in the sense that it's pretty close to unaltered. I'm going to have to take the board out and I'm going to have to desolder it to understand if these caps have been replaced. They look original. Like if you look at those solder, oh, I mean, somebody might have done a really nice job on them. But these look like original solder points, or at least somebody that wasn't a hack did them. Far better than me. Okay, let's turn this on. I think I got all the settings right. Here we go. Notice that the 0 page isn't flickering anymore because of our new trusty... Oh, it is. Well, isn't that interesting? Was that something different? Or did I fix one problem and introduce another? Or is that just part of the test? Well, we saw the character issue in the 1541 diagnostics. Let's go back into that. I'm just going to pull that out of it's per my previous fear. 1541 diagnostics looks like this. Let's turn it on and see what it looks like. Okay, so none of the weird characters are coming up. So the characters in the page 0 section of the test, we'll go back there and I'll point it out again, obviously is something else. because all the lines that we were seeing under all the G's in when this diag was up, they're all gone. So that tells me that we've fixed the major problem I was trying to fix, which was a character problem. Okay. In the meantime, shut that down again. Double check my recording. Turn the power back on. Of course, turning the power back on doesn't actually change the settings on the card. Turn the power back on, and here we go. Yeah, so something wrong with the controller. Oh. Uh-oh. Mishmash of RAM in here. Let's see here. So, main processor. Sorry. Oh, that's CIA, pardon me. Are at about 30 degrees Celsius. ROMs are at about 30 degrees Celsius. That's at about 30 degrees. Whew. Hot. That is at 37. That is 32. And the video chip is at about 36 and a half. Sorry if you aren't seeing that. This heat spreader. Ooh, that little guy there. I don't know if you see that. He's about 75 degrees. Ooh-wee. I have to check. See if that is really meant to be that hot. We check the RAM chips. And so this is about 37. These temperature testers are really inexpensive right now. You can go to the Big A store and get them at a really inexpensive rate. So that one chip there, that should be running at about 25 degrees Celsius, and we can see here it's running at about 40. U16. If I'm not mistaken, that is the PLA. I think they do tend to run a little warm. Might be why they're. That is hot 2 at 35, and that 581 is the SID chip. And it's running hot too. Whew, very hot. How hot's this now? This is up to 84 degrees. That connection to that capacitor, right there, that's 85 degrees. That going into that capacitor, sorry, out of that capacitor, 85 degrees. 32, 32, 30, 32. Well, I'd have to get another board to get references on this, but at least I've started the game. And we'll see who else wants to play. Because I think this will be a great, simple diagnostics tool. Just as certain individuals that are in the refurbishment game, quite popular online, are using their fingers, as I was, to check to see what feels really hot. Humans are very subjective rather than being objective. So we'll see if that is the case here. I also want to look at what the control... Okay, well, the 4066 at U28 so it actually says that the 4066 at U28 is bad. Maybe this board isn't as good as I thought. But who uses the control port anyway? What we don't want is this thing to go haywire and kill other chips. All right. Well, there we have it. Testing is done. We aren't going to run constant tests, but we did fix one major issue with this. I'm going to do a little research on that control port, and before I post this update, I will get back to you. So for now, I think so that cleared out. Well, didn't take much of the dust. It really needs a full brush out and cleaning. It looks like I got a bit more work to do on this. If that control port's really bad, then, which I believe it is, then I'm afraid we're going to have to replace it. Okay, I'm back. It is the next day. See, I've changed. I took some time to do some research. The control port issues that we were seeing on the test yesterday were really bugging me. So I thought I would dive in and have a look at that today before publishing that this was actually a completely fixed system. It looks like there was more than I actually originally expected to be wrong with this. So much for known good. So we're going to jump into this today. We can fast forward me unscrewing this unit, but we're gonna test this control port again, and we're gonna run some deeper tests on it to see what might actually be causing that error on the test platform that says that we have a control port issue. In other words, chip U28 4066 has an issue. So once again, we've opened up our case here. I'm just going to put the keyboard to the side. So we left off with the test yesterday that showed U28 4066 chip as being bad. Through my research, I found that there may be a few things that cause this. Of course, the chip might be bad. But the SID chip also provides some of the functionality for the control ports, including paddle and proportional mouse. And so if the SID chip is bad, it may throw an erroneous error to the control ports, making the testing harness think that U28 is bad. Another known issue out there is the control ports themselves. They have a tendency to get cold solder joints over a long period of time of people pulling and pushing things in and out of them. So we're going to test these cartridge ports independently using, in theory, a known good joystick. That's number one. Number two, then we're going to try and replace the SID chip with another potentially known working SID chip. But I don't have a spare SID chip. I don't want to go into my SX64 to pull it apart and see if it's SID, to get at its SID chip, which I believe is working. But I also haven't run a full end-to-end test on that unit again since I was having the full suite of issues from the bent up pin on the diag cartridge. So I'm going to do something that I probably shouldn't, is I'm going to go into one of my next units. I'm just going to pull out the SID chip and we're going to see if I can even get this unit to start up with it. I'll be right back. Let's see here. We have our video in and we have our power in through our power saver. Here I'm going to use our C64 diag card. There is, look at that. Okay, joystick tester 6. These two are fine. That's down, that's up. That's the exact opposite of this. Double check that I'm off. Let's plug this in. So we're going to get what I think is a known good joystick. I've played a couple games in it. We're going to get a little bit of deoxit here, wherever I've put it. Right in front of it. We're going to get a little bit of deoxit. We're going to put that deoxit on those pins. I've just dropped something there. And then I'm just going to, while it's off, because, you know, it does have 5 volt going through the joystick. Oh my goodness. While it's off, I'm going to use this and I'm just going to push it in and out. I'm also going to see how much wiggle these ports have. It is a 40-year-old machine, so, you know, we might have an issue with it. Okay, so now that we've done that, let's just use a little bit of air to blow out any excess that we might have built up there. And let's plug this in and let's see what happens. Survey says no signal. Survey says no signal because I bet you I plugged in the wrong cable. Okay. Proper 5-pin cable there. Survey says. I didn't realize that the joystick tester had music. Okay, we're in control port 1. We go up, it tests. We go down, it tests. To the right, it tests. To the left, it tests. Fire button tests. Here we go. Up, down, right, left, fire button. Okay, so the music is awesome. I guess I tested that on a monitor that didn't have any sound last time. Okay, we have pretty good confirmation that those ports, at least the pins and the items that relate to these ports are still good. The next one's a SID chip. All right, this is the next unit I'm going to work on. I already know that it shows completely dead. I'm going to just plug in the power here. You're going to see it's got a very, very dim light on it. You can barely see that. Oh my gosh. No idea what's wrong with this machine. Never had it open. This is another acquisition. We're going to very quickly go into this unit for the very first time and have a look at whether it even has parts in it. Don't know. These could have been stripped for parts and left for dead. And then somebody picked them up, sold them as is on that certain auction house, and I did not necessarily win because of that. Oh my gosh. Look at those traces in that motherboard. Wow. Here we go. Let's take off the cartridge port and let's see what's going on with this machine. Now, Dusty, I'm sure you can see it, that all this looks like it's had some sort of maybe capacitor leak, maybe water damage. I don't know. It looks like all these traces are just lifted right off the board. This one's going to be an exciting one. Maybe not even worth my time and energy, but look at this mega robust heat shield here that I am going to take off because I want to get access to the SID chip. Uh-oh. I missed a screw. There we go. Sometimes doing this blind is not a good thing. All right. So there's the donor board set aside. We'll bring back our to be fixed board. And we'll pull this its SID chip out. Maybe, if we're lucky, and of course once I pull that out, I might as well throw a little bit of deoxit in here on those items. If we're lucky, this SID chip at least works. And if this SID chip works, we might be lucky enough that it also corrects the problem. I think is a quick test. See if we even get any sound. Not even going to change the settings. Let's see what happens here. Starting up. Oh dear. I'm not hearing any funky music. Okay. So, sadly, I don't think we have a good SID chip coming out of that motherboard. Let's, I've got one other breadboard. I think what's happened here is we have harvested units that have, oh, I hope not. It's going to be fun trying to repair these anyways. Let's put it that way. But I was afraid that we might run into some units that I buy at auction that were just harvested for all of their known good chips. Now, I'm going to have to correct these legs, which I may have just created that error. Here we go. Try it again. No sound. All right. Joystick, everything else is working. Yeah, okay. Well, that's a shame. I'm going to start going through those units and finding that everything's dead. Well, I think the one motherboard is toast anyways, so. But for the rest of today, we're going to not have a SID chip, a known good SID chip to test with, which means that other board I'm going to have to pull out, visually inspect, and see if I can gather some more intelligence to possibly what's wrong with it. All right. Well, that was worth a try. A little disappointing. But of course, they're going to be challenging things for us to work on next. Hopefully I get a couple good ones out of that. Let's bring our bad boy back here. Let's get our SID chip back in place. There we go. Test cartridge is in. We turn it on. We have music, so we have a SID chip that's working, but I think you're going to see That's not a bad temperature. Well, we're going to put it through the stress test, and we'll see if it causes that spike again. All right. So back to our dead test here. We're gonna, not our dead test, our diag. Just in case I weren't aware, I've gone through a series of tests here. We're going to try and make sure that this is a functioning board. Thick one is always control port 1. We're going to put this in. Power on the power saver. Alrighty. Everybody ready? Survey said. And now we got the control port is bad. What the heck? It's not here. I'll let her run again. Well, now it says the 6581 is bad. But you can hear. There's nothing wrong with this SID chip. I'm pretty darn sure. Control port bad, and now it's saying so we know that we talked about this at the beginning. Cold solder joints, possibly the SID chip, possibly the 4066. But it just doesn't make sense that sometimes, here, I'm going to turn this off, turn it back on. It only comes back with the control port bad. And then sometimes the SID is not working properly. And then other times, it says the CIA isn't working properly. And as you saw the first time it went around, it just said the control port was bad at 4066. Then it said the control port and the SID. And now watch, it's going to say that, it may or may not, the 6526 is bad. There, you see? Now the control port. But this time, this makes no sense. What's going on? I got to go back and do a bit more research because it's doing it on this board, which is, the focus board that we're working on today, but it's also doing it on the other, surprisingly working, and it's behaving the exact same way. There we go. 6526 is bad again. Right off the bat. What on earth? I've tried the different mode. I may try and find the 586220++. I was hoping to do that in another video where we're going to use Matthew Desmond's new car. Look, there. Now everything's bad. Control port, U1, U18. What the heck is going on here? Okay, I'll be back. Okay, so I'm back from doing some research, and I think I have figured out what the heck is going on here. So I did do some research when I was looking up that issue, and I was wondering if this might have something to do with the Rev A board. Because the Rev A has a number of particular issues. It's got video issues out of the box that can be somewhat corrected by adding a proper resistor that brings the I think it's the chroma to within volt specage. The R36 and clipping the pin for the bodge wire here to allow the resert to work properly. I have done enough research to know what I think, how that actually works and why it doesn't work out of the box, but it's a known fix. And I may apply it to one of these two boards, possibly the latter one that seems to be in worse shape than this one. Hey, that's going to be a fun learning experience. But, oh my gosh, so I've got just coming back, I did the research. I found no notes about Rev A boards having this type of issue, but I think I figured it out. And with this diagnostics cart, and thanks to Retro Rewind for actually posting the manual that goes with this cartridge, or at least this version or this version of the ROM, not necessarily this VersaCart with this version of the ROM, and that's besides the point. The software that I am using to do the diagnostics, if we look under 5.11 under control port test, you're going to see, and I'm looking up at my monitor just above the camera here. So yes, it definitely checks port 1 for the joystick as well as the paddle inputs. And remember that paddle inputs are controlled by the SID. And it states that here under U18. It goes on to talk about how it does the tests. And that if it sees the input as bad, it will usually indicate that 4066 U28 is bad, or sometimes 6526 CIA U1 is bad. But there is this note here very specifically about the older 5-pin video output PCBs, i.e. a Rev A board, that the control port will display bad and indicate a defective SID sometimes, as sometimes it does and sometimes it doesn't, at U18 when the control port test runs. And this is due to the capacitors that were originally put on the manufactured PCBs at these specific locations of C48 and C93 and pins 23 and 24 of U18, which caused the digital output to fall outside the specified range, which is what the test cart software and cartridge checks for. So these two capacitors are the ones that they're referring to, C48 and C93. And yeah, mine's a little smushed down to the board. And these two are the culprits. They are the wrong value capacitor, and they should be 1800 farads. But it does state that this will not cause any problems with the paddle operation. The capacitors need not be changed if a different value cap was used at the time of manufacture, which it obviously has been. So what does this mean? This means I have just spent half a day running through this diag test multiple times, trying to wiggle the board, swap chips, including the two CIAs, including the SID chip, trying to find a known working SID chip that I can use in this, because in my Commodore 64Cs, I do believe they use the SID chip that's at a different voltage, and if you put it in this board, bad. I'll double check that, but it doesn't matter. I went after the bread bins. And
found out that these have been working all along and I've just been wasting my time. I am sure there are people right now rolling their eyes, screaming at the monitor, saying, Aaron, you didn't read the manual. Rolling their eyes and screaming at the monitor, Aaron, the Rev A boards always fail in that part of the test. Or the Rev A boards have those random failures in that part of the test, and you have to go on to do a more physical test, really, of what would be, in theory, the mouse and or paddles to know whether it's truly working or not. Hey, so I'm not going to waste your time. You can watch them in the outtakes if you want, but this is it. We have a fully functional, we have a fully functional as produced Commodore 64 bread bin just by replacing the character ROM. The original major problem that we were trying to fix until I noticed that we had the cartridge port issue. Wow, learn from this. Read your test harness documentation before you start testing so that you know some of these peculiarities. I'm going to reassemble this. And you can watch me while I do it if you want. But that's pretty much it. The next thing, I think I'll jump ahead to that supposed dead one. I'm going to clean this up. I need to do some cleaning of the cases and just a final check of the keyboard with it fully plugged in. And then I do have a known good Commodore 64 bread bin of the vintage era. This one, as I said before, I'm going to leave untouched because I think it's valuable as a collector's item. And we now have confirmed that all these caps are original. And we also have done the reference temperatures. So yeah, we'll do a reference temperature set on the next one. And I also have the Commodore 64SX, the final video on that coming up relating to just its final test on its floppy drive. Speaking of which, I've completed the tests on finding a known good floppy disk for doing alignments. I think that's it. Thanks for joining me on this journey. Are you ready for the next one? We'll talk to you soon. Cheers.